Welcome everyone to this discussion panel titled Programming in University Math Education in the GenAI Era, an event supported by the Center for Mathematics Education of the Fields Institute for Research in Mathematical Sciences. I'm Chantal Buteau from Brock University, and I will be co-hosting this panel with Amy Mamolo from Ontario Tech University and Elise Lockwood from Oregon State University. We are hosting this discussion panel from the Fields Institute located in Toronto. We wish to acknowledge that for thousands of years, the land on which the University of Toronto operates has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So the aim of this discussion panel is to provide a platform for discussing timely developments in response to the rapid advancement of GenAI in the area of programming in university math education. It builds on earlier conversations that we have facilitated and participated in regarding computational modeling in mathematics education. And we are now delighted to briefly introduce our panelists who have generously agreed to share their insights and expertise as part of this discussion panel. Irene Biza is Associate Professor of Mathematics Education at the School of Education and Lifelong Learning at the University of East Anglia in the UK. Dr. Biza's research foci include mathematical learning at the post-compulsory level and the use of digital resources in mathematics education and practices. She is Associate Editor of ESM Journal and member of the editorial board of 3 other mathematics education international journals. She has been the leader of the topic working group on university mathematics at the last 2 CERMI, that is Congresses of the European Society for Research in Mathematics Education. Welcome, Irene. Chronis Kynigos is Professor of Educational Technology and Mathematics Education and Director of the Educational Technology Lab at the National and Kapodistrian University of Athens in Greece. Dr. Kynigos has been working on the uses of expressive media to generate agency and creativity in mathematical reasoning. Through design-based research, he has studied teacher-student medium interactions and socio-constructionist classroom settings. He currently asks questions like what kinds of mathematical meanings may grow when GenAI is used as a discussant in problem posing and solving. Welcome, Chronis. Thor Odden is an Associate Professor of Physics Education Research at the Center for Computing and Science Education at the University of Oslo in Norway. Dr. Odden uses ideas from physics to study how people learn, how machines learn, and how machines can help people learn. His research focuses on how computation can be leveraged to support student creativity and epistemic agency in science learning, how students acquire disciplinary computational literacy, and applications of GenAI to do qualitative research at scale. Welcome, Thor. Finally, David Weintrop is an Associate Professor and the Dean's Impact Professor in the Department of Teaching and Learning, Policy and Leadership in the College of Education, with a joint appointment in the College of Information at the University of Maryland in the US. Dr. Weintrop's research focuses on the design, implementation, and evaluation of effective, engaging, and equitable computational learning experiences. His work lies at the intersection of design, computer science education, and the learning sciences. In support of his work, Dr. Weintrop received an NSF Career Award. Welcome, David. So the discussion panel today will consist of 2 rounds, each addressing a question by the panelists in about 4 to 6 minutes presentation, and followed by short reactions among the panelists. We will end with an open discussion to which we invite everyone here today to send us questions and comments in the chat. And we're now ready to start, and I turn it to you, Elise.
Great. Thank you, everybody, for being here, and thanks to the panelists. So I want to just present a little bit of a context for this first question. I think as researchers interested in the role of programming and computing in math and STEM education, we note that there has been research and evidence that using programming can facilitate an exploratory and active approach for students' learning of mathematics. And yet, with new technologies and GenAI, one could argue perhaps that GenAI can be an alternative to programming in this case. And so we're curious about how GenAI might interact with what we know about programming in mathematics education. And further, in the early 2000s, computational thinking skills were deemed essential for the 21st century, including in mathematics. And so again, in the future, as we consider technologies in GenAI, it may no longer be necessary to write code to create scientific computer models. And so this led the panel to form the following question, which we posed to the panelists. So which related skills and knowledge should we aim at developing when integrating programming with GenAI in undergraduate mathematics education? How might these skills or knowledge contribute to students' effective collaboration with GenAI? What might an effective collaboration with GenAI look like? And which education research, research questions and methodologies are needed to inform teaching and policy making? And so now we are going to turn it over to our panelists. First, Irene.
Thank you very much. Thank you for the invitation. Thank you for the opportunity. Give me a second to share my screen.
Looks good.
Is it okay?
Yeah.
Okay. Well, I'm the first one. Many thanks to the Field Institute for hosting this event, but to Elise and Chantal and Amy for inviting me to contribute to this panel. I look forward actually to our discussion. I will go straight to the first question. But before us starting responding to this question, I would like to look a little bit on the different components we have here. So I have highlighted in the question programming GenAI and undergraduate mathematics education. I will start from undergraduate mathematics education. And we assume here that our objective is undergraduate mathematics learning. So we aim learners to develop and appreciate undergraduate mathematics practices. When we bring programming to the picture, we see the mediating role in achieving the objectives I mentioned earlier. So in practice, through programming, mathematical practices expand, for example, by facilitating computational processes, experimentation, or modeling. Somebody may argue that not only learning, but also mathematical practices are altered with the mediation of programming. Some mathematicians may disagree with me. It happened to me in the past. By saying that mathematical content remains intact, regardless the use or not of programming or other digital resources. But from the learning perspective, there is a dialectic relationship between mathematical content and use of digital resources, in our case, programming, but also with the learner. So I see programming and undergraduate mathematics education in an interrelation rather than as two distinctive agents in the process of learning. And I would add to this interrelation the students and teachers as well. Now, if we bring GenAI to this picture and this narrative about the interrelations, I see GenAI as an additional agent, quite complex, with significant affordances, and to make things quite more complicated with human-like communication characteristics. Don't take me wrong, GenAI and artificial intelligence technologies in general are not humans. Sometimes they are beyond human ability in the collection and synthesis of data, but they lack human ability in inquiry, creativity, contextualization, and critical judgment until so far. Sometimes, however, we attribute, not only our students, but us as researchers or as teachers, we attribute to GenAI human behavior. I reviewed a paper recently in which researchers accused GenAI of a logical failure in a linear algebra response. A response that, although it was correct, it was not the shortest and the most, not the most straightforward one. So in practice, GenAI refused a response that has less probability to be used, while researchers interpreted this refutation as a logical gap. So if we go back to the interrelation, a programming undergraduate mathematics students and teachers, we have an additional agent here, which is GenAI. And I will use this multi-agency idea to respond to the questions. In terms of skills and knowledge that we would like students to develop in this new frame, I would say that we would like to see more questioning skills, to see to develop students' ability to unpack tasks, identify critical points, ask appropriate questions. And that comes together with critical inquiry skills. So students need to be prepared to question, challenge, to unpack AI produced outcomes. And also, we need students to know what GenAI can do, cannot do, or can do differently or not so well. So they need to develop skills to recognize potential limitations and learn how they can benefit from the AI capacity and anticipate and, if possible, address AI drawbacks. So the question is how those skills can be developed. We are in the field that it develops as we speak. So some ideas here is that comparison of GenAI integrated and GenAI free programming might be a way to identify differences. Through engagement with GenAI integrated programming with triggers for debugging, questioning, inquiring, and also through goal-oriented activities in which students with GenAI integrated programming actions can achieve a certain goal. And we may have the chance to talk more about this in the next question. So if we think in terms of the research questions, less than a couple of years ago, we conducted a Delphi study and we invited teachers, administrators, researchers to propose some questions that they would like to investigate in terms of the use of GenAI in university mathematics. And they brought up questions about students' interaction with GenAI, for example, how students use GenAI to support their independent study. About teachers' interaction with GenAI, how can GenAI be used, for example, to support the efficient marking of exam scripts? Or to what extent can GenAI be used to generate examples that are illustrative for particular topics and concepts? And when we went through workshop discussions with different stakeholders, university mathematics, education researchers, teachers, but also colleagues who are involved in leadership and administration, it seems that there are differences in their priorities. teachers want to facilitate students' learning, to make their everyday job easier, while those in leadership role prioritize strategic institutional integration, particularly highlighting the necessity of aligning GenAI use with broader curriculum development and workforce readiness goals. But researchers, on the other hand, um, the, they appreciate questions with attention to conceptual rigor, methodological clarity, and critical evaluation of GenAI reliability and validity. So I think in terms of research, we need some attention on institutional, but also on stakeholders' considerations. Thank you so much.
Thank you so much, Irene. Okay, and now, Chronis, if you can share your screen.
Right, I'll share the screen. Can you all see?
Not yet.
Yeah. So I was intrigued about
Chronis, we can't see your screen yet.
No?
No.
Hang on. Did I share? Is this okay?
Yes, although maybe you can put the slideshow. Yes, perfect. Great. Thank you.
Yeah, so I was intrigued by the text and the questions. So my presentation is not just about answering questions, but also a reflection on asking questions, because I feel that this is an emergent phenomenon and we need to continually reflect on both fronts. So one thing that I noticed was that even in the text, there were inherent divergent points of view of how GenAI would be used by whom. For instance, in the computing world, the idea of GenAI, there's this idea of getting results, creating pieces of software or getting code produced in an effective way, which is overbearing and very important. In mathematics, there's a view that it may enhance mathematical investigation for researchers. So the focusing on mathematics education, I think, is quite distinct, and we need to train ourselves on how to focus about the perspectives and the interests that, as mathematics educators, we have, and the value of programming for engagement with mathematical activity, like Irene mentioned. So within mathematics education, we can also split the perspectives into two strands. One of them is education and the use of GenAI for enhancing traditional approaches to math education. So get intelligent tutors to help us respond more effectively to questions. But there's also the idea of approaching education as a transforming institution, a transforming process, and focusing on mathematical learning and competence building. So the idea of mathematical problem solving and the competencies needed for the education of critical interactions with GenAI. So the value of integrating GenAI in programming for mathematical learning, focusing in on what the panel is about, is we ask questions, where is there an added value in pedagogy of math education, of programming with math education, in using GenAI? And I think this question is not obvious, and we should be looking. We have enough problems with math education and with the ways students learn or engage with the generation of mathematical meaning and competencies. Does GenAI help us address these problems? And then we can think about what new competencies may arise through situations where students interact with these tools. And also, we need to start becoming explicit on when is it time to think about guarding ourselves from the adverse effects of using GenAI. So I've got this little provocative title in this slide: is cognitive offloading good for you, and when? So how can we teach students the agency of what to offload and when. So how can we get students to think in the following way? I can use GenAI to provide the solution, but let me choose not to use GenAI because I like getting my brain to work, or I like hard problems, for instance. So when is the idea of cognitive load valuable for mathematical thinking? And how do we generate in students and in teachers the value of a gentile stance towards offloading, and how does that look like? How do we teach it? What new mathematical concepts, thinking styles and practices can be learned through this discourse? So to conclude, what's the point of preserving cognitive load when programming? We can say thank God for GenAI. Now we don't have to think or program anymore. Hooray! So how do we turn this around? Because AI will increasingly allow offloading in the programming activity in general. And we need to reconsider if there is a value of programming competence, if there's a value for this kind of competence to remain as a vital part of human intellect, or is it something that we had obstacles with, and now, thank God, technology is advanced and we don't need to bother anymore. So if there is a value in that, how do we argue for the value? How do we convince other people that there's a value in breaking our backs to write a program, because we gain something from it, we are empowered? And what exactly do we teach? Thank you.
Excellent. Thank you so much, Chronis. That's perfect. I think David is up next.
Yeah. Great. Thank you. And are you guys see my screen?
Perfect.
Well, first off, thank you for having me. Thanks for giving me an opportunity to share my thoughts. In some ways, I'm going to kind of pick up where Chronis left off. In first thinking about knowledge and skills that are kind of central to this discussion. I was at a symposium 2 weeks ago, and there was a speaker who was talking about the way that, kind of the same topic we're talking about now, the way that mathematics education, he was thinking K-16, but the way it needs to change in light of these new technologies, new tools, new powers that come along with generative AI. And what he was arguing for was an increased emphasis on problem formation and abstraction, i.e. kind of setting up the thing that needs to be done, less focus on the calculation piece, and then more focus again on interpretation of results, which is kind of like offloading some of the calculation, the manual work to tools, which at some level feels pretty comfortable, but to me feels a little bit like we're describing the equivalent of what vibe coding is with the emergence of GenAI, where we think a lot about what the problem is, and then a lot about what we get to the end, but like the details of implementation become less important, and we can just kind of vibe code our way through it. And I challenged him a little bit about, like, well, how do we feel about this idea of vibe math? Like, are we okay with backgrounding kind of the calculation and the conceptual underpinnings, but getting to a result that we feel okay about? And I think collectively in the room, we didn't feel really great about vibe math. Whereas we're a little more comfortable with vibe coding in that it's not just about coming to a final answer or product or piece of software, but that conceptual understanding of what's going on and how it all fits together is essential. And that conceptual understanding is essential for then, conceptual mathematical understanding is then essential for informing how we approach questions, how we break them down, how we interpret the results that come from them. And so that's a long-winded way of saying my way of thinking about this is that the role of generative AI needs to be in support of kind of developing that foundational understanding and intuition around mathematical understanding. As for the knowledge and skills that I think go along with that, the way that I've been talking about it in my own work is using this acronym of REPS-AI, responsible, effective, and pedagogically sound, is kind of like the key ingredients of what I want undergraduate students to know about how and when it's appropriate to use generative AI tools. Responsible being aware of kind of ethical implications, limitations, potential environmental impacts, just kind of when do we feel like this is an okay, safe thing to do versus when is it inappropriate. Effective meaning kind of knowing how and when to use it in ways that kind of get you to answers and outcomes that are desirable, kind of effectively and efficiently. And then pedagogically sound is getting back to this Vibes Math idea of that the learning disciplinary content remains central to the undertaking. So it's not as a way around learning the mathematics, but it's a way in service of learning the mathematics. And so the knowledge and skills that I think are associated with this Reps AI approach, my background comes from computer science and computer science education. So I do think understanding foundational programming constructs remains useful because, again, that's the building blocks with which we were going to kind of construct and explore these mathematical ideas. An increased emphasis on debugging, understanding limitations and potential of AI tools, knowing how to test and evaluate solutions that come out, having a bit of intuition about what generative AI tools might be doing, especially if the thing that they're doing is producing pieces of code that are running to kind of test or demonstrate or express mathematical ideas. I also think there's a parallel set of metacognitive skills that go along with this in terms of things like self-regulated learning, critical reflection, help-seeking behaviors of students pausing to think about what is it that they're asking generative AI to do? What is the mathematical content or ideas that they're being asked to explore, the relationship between those two things? If and when generative AI starts, the tools that they're using start to produce results that they themselves don't fully understand and interpret, like being able to acknowledge, like, wait a minute, this is going to step past what I understand, or I'm not sure why these things are happening. And doing that metacognitive work, because you're able to offload parts of the process, I think developing those skills and helping students better understand how and when to kind of pause or ask clarifying questions or kind of really poke and prod at these agentic tools that they're working with become increasingly important. There's also a sub-question around collaboration that I think is really important to think about. And I heard this expression from a colleague of mine, which is moving away from generative AI as a sage on the stage, i.e. this oracle that has the answers that you can ask for, and instead shifting more towards a guide on the side, which is retaining agency with the learner and looking for kind of supplemental support and clarification, as opposed to, right, this is not thinking about it as a professor or instructor who has the answers, but instead more like a tutor or TA to kind of help support you along the way. Again, getting back to an idea that I raised before, I think this idea of helping students know when it's appropriate and pedagogically sound to relinquish control of the work that's happening, i.e. like offloading some of the grunt work or some of the calculations work, while also kind of having confidence of knowing what is happening and how to make sense of it. The other thread that I see running through what collaboration and the role of GenAI in mathematics education is making sure that collaboration remains authentic to the task, authentic to professional practice, authentic to the discipline, kind of, again, keeping central the mathematical concepts and practices that we're trying to teach students, and not kind of turning this into a space where, right, we get into this like vibe math area where generative AI is doing all sorts of kind of atypical, unconventional things that eventually get you to where you're trying to go in the end in terms of a reasonable or correct answer, but instead is a process that right remains pedagogically sound and with respect to learning the outcome, as well as kind of following through steps that are consistent with conventional mathematical practice. Okay, with that, I will relinquish my screen sharing and pass it along to, I believe, Tor might be next.
Yeah, perfect. Thank you, David.
All right. Can you folks see my slide?
Looks great.
Perfect. So I want to make an argument here, and I'm framing it that way because I want to be a little bit provocative and offer up a potential model for this that I'm not totally 100% convinced of, but I'm becoming increasingly convinced of. And that argument is that we should start thinking about training our students less as students, less as individual researchers, and more as if they were research group leaders themselves. So this is something that I'm seeing coming out of a lot of different fields. I just read 2 articles yesterday from different social science fields that argued this exact same idea, that basically we are now at a point where every person, every researcher, and every student has access to not just a super intelligent AI system, but potentially an entire team of super intelligent AI systems that they can use to explore different ideas, that they can use to propose different topics, different questions, and then have them sort of follow up on those questions and then come back with results that they can evaluate. And this is very reminiscent, I'll say, of the experience that I've gone through as I was a PhD student and then a postdoc and now a research group leader, of sort of relinquishing control, where earlier I was the one who was doing a lot of the research myself. And I was there on the ground, I was analyzing the data, I was posing the questions, I was writing the papers, I was doing sort of everything start to finish. And more now, I'm in the role of providing the initial questions, providing the guidance, providing the start point, and then having my own students now follow up on that and check in with me from time to time. And I suspect that in a lot of knowledge producing fields, this is the way that things are going to go, where people are increasingly going to be using AIs as tools to explore different leads, explore different ideas, explore different possible questions, and then report back and evaluate sort of what they have seen as a way to cover more ground and explore significantly more than we have otherwise been able to do. So the question becomes then, what do people need to know in order to be effective research group leaders? And obviously, you need a certain amount of basic competencies. You need knowledge of your discipline. You need knowledge of how knowledge is produced within that discipline, how research is done, how work is done, right? Like, you cannot escape from that. A person who doesn't have that foundation is never going to be a good knowledge producer and never going to be a good research group leader. But I suspect that we're going to see more and more emphasis shifting over to the skill of asking the right questions, knowing where the gaps exist, where the interesting sort of tantalizing possibilities exist for generating knowledge. And, you know, not just necessarily at sort of the research level, but we're talking about mathematics students here. So knowing where their own knowledge breaks down or where interesting investigations are that they could pursue. And then being able to evaluate the quality of responses and knowledge to be able to use AIs as a tool for this kind of agentic exploration. And so as researchers, we then have this task of understanding what the essential skills are that change between sort of the traditional path that we have seen of training people up as undergraduate mathematicians and graduate mathematicians, and eventually potentially research group leaders, versus in this new age. But this is one place where I think we have a real big advantage, because there are a lot of different fields that have gone through similar transitions. In a lot of fields, there are two different pipelines to professionalism, one which is an apprenticeship track, and the other which is more sort of training in a leadership position, right? In militaries, you have non-commissioned officers who are enlisted and gradually work their way up through, and you have commissioned officers who go to military school, learn the skills, and sort of come in a leadership position. And they serve in different roles, and they learn different kinds of skills. You see similar things showing up in fields like journalism, where you have some people who sort of come up through the copy room and other people who go to journalism school. You see the same thing in the culinary arts, where some people start as dishwashers and eventually work their way up to be cook versus going to culinary school. And my sort of provocative suggestion here is that we can look to some of these other fields in order to understand what it might mean for our own field, where people have traditionally kind of always worked their way up from sort of apprentice mathematician all the way up to mathematics researcher, research group leader. And now potentially even the apprentices will have access to a team of researchers of their own.
Okay, great. Thank you so much, Tor, and all four of you. We now have just about 3 minutes, so we at 12:10 Eastern, we would like to move on to the next question. So if there are just any brief reactions that the four speakers would like to make on any other panelist talk, that would be great. But we only have about 3 minutes, so I'll raise my hand at the end of that to move us on.
To quickly respond, Tora, I appreciate your presenting kind of a provocative idea, because it's certainly useful for generating discussion. for me, this is very interesting coming from a computer science perspective, because what it means to be a software developer has shifted from sitting down and writing code and to now talking to friends and colleagues. They're managing teams of these agentic programming tools, which on the one hand greatly increases their ability to kind of do things, right? They're supercharged because they have this team of agentic developers doing things. But it's also presenting a little bit of an existential question in software development, because it's in some ways it's cutting off the bottom rungs of what this ladder looks like. And so the only after having spent time doing the coding yourself would you have the right set of skills to kind of lead and manage the team. And so it's really interesting for me to think about, does it, and I think your example of kind of like going and being trained for leadership versus kind of working your way up by doing the things themselves, like how, if that breaks down when thinking about mathematics, like is there a world where you never quite learn and develop these foundational pieces? You just kind of black box some of the foundational mathematical pieces and know that they exist and that like the outputs will look like such and such. And then you're just coming in where you're offloading these calculation and computational pieces without ever having done them themselves, which again gets back to a little bit of this vibes math idea for me, where you're kind of black boxing things that historically have been necessary. And so now we're saying if they're not necessary, do we still need them? Very provocative.
I want to give a 10-second response to that, because the thing that I love about the fields where these two exist in parallel is oftentimes people have complementary roles, right? Like the people trained in leadership from the start have kind of a different role than the people who come up through. And I suspect we're going to see something similar here.
Thank you. Yeah, and Chronis, go ahead. I think we have time for a comment.
Yeah, just a very quick idea. We give value to students being able to explain and find a language with which to explain their own thoughts. Maybe we should now start thinking about focusing on a language to explain how they interact with the GenAI tool. So what kind of prompts they ask, why they ask these prompts, what kind of answers they get, and how these answers help. So this is a language which we, I don't know, I feel quite ignoramus about using the right words to explain how I interacted with a GenAI tool. And maybe this is one of the tasks we need to think quite deeply, quite quickly.
Excellent, thank you. Yeah, and Irene, just if you brief comment, go for it.
Okay, very brief, and I think we will continue this discussion later on. I'm following the provocative suggestion from Tor, and it is in order to be a good research group leader, you need to know your discipline. And what we have here, and it is part of our thinking, is that you learn your discipline while at the same time you are asked to be a research group leader. So this is something that we need to address. And also in terms of the apprenticeship, it is studying mathematics may have different pathways. People study mathematics to be research mathematicians, but there might be accountants, there might be teachers. So let's. I think this is very interesting. Thank you for the proposing those ideas. I think we can continue later.
Excellent. Yeah, thank you all so much for your comments on that first question. And now I'll turn it to Chantal to proceed with the second question.
Thank you, Elise. So now moving on to this question, because GenAI is already present and being used by our university students, we now want to focus more on implementation, considering ways that we might want to react, adapt, and potentially use GenAI in our integration of programming in university math education. So in the conclusion of their literature review, Pepin and colleagues claimed that GenAI does not pose a threat to mathematics education, and that when carefully integrated, ChatGPT can help students develop problem-solving skills and adapt to different learning styles, and ultimately contributing to more dynamic and inclusive math education. So in a similar vein, Sahin and Bidehan suggested that, or argued that key challenges the ones that we know about, cheating, plagiarism, and hindrances to student cognitive development, might not be as salient as proposed, and that they can be mitigated by appropriate guidance from teachers, such as promoting academic integrity or a critical stance towards AI-generated arguments. So this led us to this second question. According to you, what would be the characteristics of a careful integration of GenAI with programming in undergrad math education? What form of assessment could best support that integration? And which educational research are needed to inform teaching and policymaking? And so we'll start again with you, Irene.
Yes, let me share again. Okay, can you see my screen?
Not yet.
Okay. Oh, sorry. I didn't press the share button. Is it better now?
Yes, thank you.
Great. So, I thought a lot around the careful integration, and I was really intrigued by this characterization, careful integration. I'm not sure what this careful integration might be. I'm thinking of something that we need to reconsider is the learning objectives when we discuss about teaching and learning in our case. We need to step back a little bit and reconsider some of the things we assumed traditionally. And but there are multiple learning objectives in our case here. It might be the mathematical content, the undergraduate mathematics, but might be programming, might be the use of GenAI, and all of them together. That if we manage to pin down those learning objectives, we might be able to make our life easier in identifying a good integration. I mentioned earlier the skills and the knowledge we would like students to develop. And I think it was used by all co-panelists, the word agency. We want students to develop agency during their learning process. But we need to acknowledge that GenAI is part of the game. So it should be a legitimate agent in that picture. And it's my turn to say something provocative here. I do believe that with the introduction of GenAI, even the mathematical content and the mathematical practices as we used to know it, they change. So what is happening is that the learning outcomes, programming and mathematical outcomes, the assessment where these outcomes have been achieved, and what justifies and evidence of this achievement, all of them are wobbly. I can share an experience from my module. I gave to my students a problem to solve. It was part of their portfolio assessment, and they could do this task at their own time. And the problem I designed carefully, it was a geometrical problem about symmetry. And splitting a piece of rectangular area in two parts with one line, but there was a hole in part of this rectangular area. And some of the students came with responses coming from ChatGPT. I knew that it was coming from ChatGPT because I tried myself and I found the response of ChatGPT. And some of them copied the response directly to their answer. The interesting thing here is that although I have thought around this problem in geometrical terms, in mathematical terms, the students came back with a response coming from physics. They talked about centroids and weights, brilliant things I haven't thought in advance. And this came because ChatGPT suggested that. So what we observe here, we observe students going outside the boundaries we define as teachers and as those who assess, and we oh, I can see the rockets. And it goes beyond these institutional boundaries of the knowledge we would like to assess. So we need an assessment that combines, if we go for traditional methods, for example, controlled exam environments, this must be paired with creative methods like portfolio and projects, because we want the students to develop skills that have to do outside the closed book examination. But when we go for creative methods, we should pair those opportunities with something that will give to the students the opportunity to defend their work. This might be an oral assessment, a presentation. So we have a complicated landscape ahead. So we need, in terms of research, a lot of teaching innovation in terms of teaching, assessment, interventions with design, implementation, and evaluation. And we need theoretical perspectives. It might be expansion of existing ones that can capture this multi-agency I started with. Thank you.
Thank you, Irene. And now Chronis.
Right. So, question 2. Well, one of the things that are maybe obvious, but at the same time obtuse, is that we are a very unique generation of people in their late years, and GenAI has just fallen off our lap. So one of the things that are made visible is wonderful and intriguing ways in which people use GenAI, like Ken Khan. But we maybe not keep in mind that these people have been brought up in a context, in a generation which did not have GenAI. So the ingenuity is an ingenuity which has emerged from the times when GenAI wasn't there. Now, math students that we have currently only started using GenAI a few years ago. So a lot of learning had already happened before that. And what happens every year where new students come up at university, and they have met GenAI earlier and earlier until we get to the point where they were born with GenAI. How do we address mathematical thinking and programming in these generations to come? Now, one of the things I wanted to draw attention to is some things that we could do as math educators or as designers and developers of contexts and tools for students. One thing we can draw attention to is this idea of black and white designs, which means at which point do we want students to have transparent tools, and what kind of things do we want to have ready-made, black and box infrastructure behind these tools for students to be able to focus on the development of mathematical thinking. For instance, I haven't seen anyone yet. I'm hoping there are people who are already thinking about designing specialized GenAI tools for math education, tools which are intentionally unhelpful and intentionally dumb at certain points in time, so that students can react to this kind of provocation from the GenAI system. And also my pet term, half-baked designs. This is didactical engineering, where we get students to be able to question things that are by our own intention engineered to be faulty or engineered to be wanting. So I think the ideas of fallibility in math education and the value of inviting refutations to propositions that students make, we should revisit them in the era of GenAI. Also, for instance, there might be grounds to think in terms of a specialized prompt curriculum, specifically for programming for mathematics, a line of prompts that students could think deeply about what they mean, what they may produce, and how the machine operates when these prompts are being put to the GenAI systems. And finally, Yasmin Kafai's idea, not within math education, but coming from the constructionist community, to find ways and contexts where students may design and develop baby GenAI systems themselves. With respect to assessment, I think there is ground for some new thought. Now that we have tools where machines can collect everything that students may do in their interaction with digital media, we may want to think about algorithms that get these machines to gradually appreciate what is of value to humans in students' programming. So all this analytics that's gathered, how do we interpret it, get machines to become more and more clever and acute in understanding what we value with response to learning. And finally, there was a phrase at the beginning which I was thinking. Our aim is to discuss timely changes responding to quick advancements. So the changes, because we want them to be timely with respect to quick advancements, the changes need to be even quicker than the quick advancements. And we know that in education, it's impossible to be flash fast with respect to the way that we respond. So we need to think deeply about these three perspectives: the curriculum to increase explicitness in teaching mindset features, such as how to cultivate agency, creativity, and competence in students, and how to get them to value these things, and how to get them to enjoy hard fun rather than engage solely on TikTok and social media butterfly kind of existences. With respect to teachers as well, we need to help teachers become more and more explicit about what they are observing and about the ways in which they are intervening in contexts where students interact with GenAI, and also to be knowledgeable about potential adverse effects of GenAI. So with respect to research, there's a lot of problematic areas out there addressing mathematical competencies that are cultivated in programming with GenAI cultures, and how to discriminate human reasoning and human representing in such contexts.
Thank you.
Right.
Thank you, Chronis. Next is Thor.
All right. So going off of some of the themes that we've already heard here so far, and kind of building off of my provocative start, with regard to careful integration, I'll say that I think one of our goals needs to be to retain the core skills and knowledge that defines the discipline of mathematics in this case, right? There's a certain disciplinary identity, and there's a certain kind of mindset, there's a certain type of skill, there's a certain culture, a certain identity that is there. And I'm not arguing for changing that. I think that core needs to be retained. But the thing that I really see as exciting here with regard to AI and kind of building off of the model that I'm presenting is that it might open up space for more exploration and evaluation of ideas. The term epistemic agency or student agency is really relevant here. Giving students additional agency in what kinds of questions they are able to ask in the course of an undergraduate education in mathematics, and especially regarding programming, and how they evaluate the quality of the knowledge that is produced and the responses, especially within sort of a community of students who are all working on either the same question or different questions. I think this is where we really get something new with AI, because traditionally it has required a lot of overhead for students to try to pursue new to them knowledge and pose new ideas and follow up on those ideas. And with AI, the threshold for that kind of work has become significantly lower. And I think that means that we can integrate it more deeply into the discipline using AI. With regard to assessment, here again, I think a lot of elements should look the same as before. And I actually kind of want to load that term before a little bit, because here at the University of Oslo, we are talking about the fact that we are going to have to scale back home exams, which have become increasingly popular and prevalent across campus, and go back to an even more traditional form of assessment, since it's no longer clear when a student turns in a home exam how much of the work is actually theirs and how much of the work was done by an AI. So I think we have many forms of assessment that have a lot of backing behind them that we can fall back on or carry on. But the thing that I would add, building off of the point that I made earlier, is I think we can start assessing students on the skill of evaluating content quality and argumentation quality. In other words, if we expect that students are now going to be using agentic AI as a tool in knowledge building, then they should be able to evaluate the quality of the knowledge that is being built. And I propose that that should be something that we include on the assessments then, in order to certify that our students are meeting the learning goals that we are setting. So basically, the student acts as the examiner for the AI. Regarding the educational research component, what role does educational research play in all of this? The thing that I am missing right now, that I'm most looking for out in the research literature, is good qualitative studies of mathematical, and I will say that includes a lot of other things like physical reasoning, with computational thinking and with AI. I want to see how students' reasoning, how their learning processes, how their approaches to these kinds of learning tasks that we put them to changes when they have AI as a tool to lean back on. What looks the same and what looks different? And here I have sort of a challenge to the research community at large, because we have an enormous amount of research to build off of that has led us up to this point. We have decades of research and established knowledge on how students learn math, how students learn computation, how students learn physics, how students learn all of these different disciplines, wonderful theories. And I want to see people using those theoretical frameworks and that theoretical machinery that has already been established and applying it to this new problem of AI. Essentially, treat all of the research that has come up until now as your pre-test, as your pre-studies. And now I want to see the post-studies. I want to see people doing much the same thing, but with AI integrated into the system, and see how it is qualitatively or quantitatively different before and after.
Thank you, Tor. And David?
Great. Thank you for those ideas, co-panelists. So the way that I think about careful integration has a lot of similarities to things that we've heard before. To something Tor just mentioned, I think there needs to be a clear understanding of focal learning objectives. I think my contribution here is those focal learning objectives is not just the core mathematical concepts, but also thinking about what are core focal learning objectives with respect to the use of generative AI in the context of using and employing these mathematical concepts. I think time and care needs to be given to thinking about, and this comes back to this idea of reps AI I was talking about before, responsible, effective, pedagogically sound. we want students to know how to use generative AI tools in reps AI ways for conducting and carrying out mathematical explorations. And so for me, I think that's part of that should be included and considered when thinking about core learning objectives for these educational contexts where generative AI can play such a central role for developing these concepts. Careful integration also, I think, should include careful guidance around what it means to be pedagogically sound, how, where, and when GenAI tools can be used. This comes back a little bit from my own experience in graduate school. In my statistics class, I was trained by a world-class statistician, and we had classes where they would say, we want you to go through and calculate these statistical tests by hand, which meant through Excel, but like we want you to kind of go from the raw data and kind of calculate steps along the way. Full transparency, you will never do this again. From this day forward, it's like a menu and a drop down or a command you type in, but going through it once to kind of understand how we go from this raw set of data and what these interstitial steps look like to get to where we are in the end, building that intuition and understanding kind of how that process works and machinery works, they felt was really pedagogically productive, and I came away feeling the same. Not that I'm sitting down and manually constructing Excel formulas, but kind of understanding when I black box a statistical calculation, I've actually peeked under the hood once and kind of wired up that machinery once. I think that's a really productive thing to be doing. And so thinking about careful integrations, where are the times where we want to go through that admittedly manual process to kind of build that intuition and understanding. I also think it's useful to not think about this as a binary integration. There's either time for GenAI and it's either all GenAI or not GenAI, but thinking about what that spectrum looks like. I think in this, to what Tor's saying, like time for open, exploratory, use these powerful GenAI tools in any way you see fit as you're exploring these mathematical concepts. We want spaces for that, but I think we also want spaces where let's put that to the side and do this pen and paper or the contemporary equivalent of that. And then there are also spaces in between where parts of it might be a little more kind of traditional old-fashioned manual, and there are times where you might offload some of the computation. And again, in understanding all these different spaces across the spectrum, I think that can develop this meta-knowledge around what is responsible, what does reps AI usage look like in terms of when is it fine to just have a single command and do everything and trust that and have confidence that what you get back is reasonable versus times you want to kind of break that down and do it step by step. And then thinking about the goal here is not just developing mathematical understanding within the bounds of the classroom, but preparing for students to use these ideas when they're beyond the classroom. And again, that's where I think some of these developing kind of understanding what the spectrum of GenAI use looks like, or the metacognition associated with how and when to kind of ask the right questions and probe the responses, or ask the GenAI for explanations of what it just did. Building those skills, I think, are equally important and are an important part of careful integration. In terms of implications for assessment, a little bit tied back to what I was just saying and what I said toward the first question is I think authenticity is really important. We want to be asking them questions that might have multiple answers, questions where there's different pathways, but then being sure that students are able to explain and justify the decisions that they make along the way. I think we want assessments, again, this is thinking about the spectrum, where there are times where it's an open-ended GenAI forward exercise. There are times where there might not be any GenAI usages allowed, and having assessments at different points along the spectrum. And then this last piece, and this is what I've adopted in my own teaching, is this idea of generative AI bibliographies, where for the most part, it's a pretty open-ended, use generative AI however you see fit. But that any assignment that you do that uses generative AI, I want you to include a little bibliography where you explain what exactly you did, what prompts do you use, what tools you use, why you think that's an appropriate and responsible, safe thing to be doing, and then how you verified and validated the responses that you get back. Again, this is building this meta-knowledge that do this reflection and asking questions about how and why am I going to use it, and then how and why am I confident in the responses that it gave. Which I think, again, towards authenticity and just building this responsible use of these tools so that when they go out into the world and it's not for a grade or there's not concerns about academic consequences, but they still have built up those practices of being careful and responsible and thoughtful and critical of the uses of GenAI. Thanks.
Okay, thank you, everyone. We now have a little bit of time for initial reaction among you four, the panelists, before we go for discussion. So whoever wants to start. Irene?
Yes, thank you. I would like to ask David a practical question about the Gen AI bibliography. This is a brilliant idea, actually. How do you implement this, and how do you persuade the students to be honest? Because something that we are working on is to make Gen AI as part of the work and not feeling guilty of using it.
That's a great question. I should say that this generative AI bibliography was not my idea, but I can't remember where it came from. I mean, but for now, it's just an honor policy. We don't have a great mechanism for, and if others have ideas, but this is kind of a perpetual challenge. We don't have a great mechanism for, evaluating when they might be using it but not disclosing it. But so open to ideas. But even just like the decision to reiterating these meta questions around how, why, when, and like why I can feel confident in it. I think the more time students spend wrestling with those questions, and not just in math, in math class, but kind of across, given the ubiquity or the broad potential of these tools, just having that building up the like part of what it means to use generative AI is to ask these critical and reflective questions about it. I think it's kind of a core goal of mine. I think needs to become a core educational practice across higher ed, because that's what I think the reality looks like now and will be moving forward.
Any other reaction before we move on to a more open discussion? If not, then maybe we move right to the discussion. I believe we have received one question. I leave it now. I pass it on to Amy for this part.
Thank you. So many interesting ideas, and I was really interested in the connections across the different perspectives that people brought together. One of the questions we've received from the audience is around the main point of higher education. So she'd like to ask, what is the main point of higher education in today's time? To award a piece of paper, a degree, to teach employable skills, to cultivate responsible citizens. I want to give my students a good reason to attend classes and lectures, and I'm finding that more and more difficult.
So we're going to start with the small questions, the small, easy questions.
Yeah, ease you in, gentle, non-controversial.
Sorry, please.
Please go ahead. It's okay. I'm just. I was getting ready to react to this type of question. So thank you very much to whoever asked it. I think because of our history as math educators, we have been brought up to feel that the value for math education and for people thinking logically and engaging in rigor and all of these nice things that are characteristics of mathematical thinking, that this value is constant. And I think the math education community should start looking outwards much more to see what's happening in the wider community. For instance, we are living at times where the main focus is on how to deprive students of this dangerous technology, which is on social media and butterfly TikTok addictions and stuff like that. So we need to find arguments that are more explicit about what the value of mathematics education is in university life, and what does lifelong learning of thinking logically and being able to to argue in a logical way, what is the value of that? So I think this is an emergent phenomenon where we are put in a position where we need to find words to argue for things that were taken for granted in the past. And the same goes for COVID and online learning. I keep trying to find reasons why face-to-face interactions are good for you, and to get students to value coming to the university so that we can have face-to-face interactions. So there's this kind of phenomenon, going back, questioning what we are about and finding arguments for things that we were taking for granted up until now.
Thank you, Chronis. Claude, do you have a response?
I was just going to ask David, did you have something you wanted to add before? It sounded like you had.
Thank you. The one thing I was briefly going to mention is, I think a lot of these ideas that we're bringing up and questions that we're tackling, that we're wrestling with, are not unique to math education. It's a challenge to higher ed broadly. And so to the question, the point of higher ed, I think about it very, very high level, is to prepare students to succeed after graduation when they go out in the world, and that can mean lots of different things. And so then this acknowledgement of the ubiquity of these tools, and as much as some of us might like the GenAI genie to go back in the bottle, that is not the world that we're living in. And so building up these kind of meta skills to prepare around reflecting this Reps AI critical uses of these tools is not exclusively a math education exercise. It's right. This also has to do with, like, well, how am I going to buy a car, or like, what, investments should it, I don't know, invest, like health and medical questions, right? So using a two-way street in terms of using mathematics as a context to develop and to learn about how to effectively use GenAI tools, but then also GenAI tools as a way to effectively learn and develop mathematical ideas and intuitions. I don't know, just some thoughts, but I'll stop rambling.
Irene.
So,
oh, sorry, is there a response before we go to Irene?
Well, I did also have a response. I just wanted to make sure David got a word in, I guess. But you said several of the things that I wanted to sort of lift out. Obviously, we are trying to provide students with a good experience while they are on campus. And a big part of that is sort of the social learning community and environment. But of course, that's a very limited time frame, only a few years. And then they have kind of the rest of their time that we need to prepare them for. And the thing that I see over and over as I talk to friends and colleagues and family members who are going off to industry is that a lot of the value of the preparation that they get here is figuring out which questions to ask and which tools they have at their disposal to attack those questions and those problems, especially when we're talking about things like code and computational analyses. I know several people in industry, for example, who are data engineers, data analysts, data scientists. And I think that's where these AI tools become really, really powerful allies, because if used right, they can allow you to sort of break out of the individual silo that you start out in, where during the course of a 3 or 4 year degree, there is only so much that you can be exposed to. And they can potentially give you ideas, give you suggestions, give you sort of access to a wide range of things outside of that very narrow band of things that you have been trained in, which I think is a real service and something that we should be helping our students to practice and learn already while they're on campus with us.
Thank you for that response. Irene, over to you.
Yes, I will follow what Tur said about the profile of the students who study mathematics in higher education. It is they have different aspirations, or they are prepared for different professions, and that affects their training and the skills they need to develop. So this question actually opens a lot of uh, opportunities for discussion on what affects mathematics education in higher education. And to add to this picture, it has to do also the financial and administration model of higher education institutions. Because if they work with a model of the client service model, they want to prepare the students for what the market needs, and they develop the curriculum at the university according to the needs of this market. And something we have observed when administrators or curriculum developers at the university, they try to address those needs. And some institutions, like our institution, for example, mathematics departments, they try to attract and recruit students, otherwise they cannot survive in the institution. So that this is part of the picture of what we want, what we promise to our students, and what we would like to achieve by the end of their studies.
We have a few more comments and questions from the crowd, and one is around how we might think about AI and mathematics education from the lens of social justice and equity. For example, not all students have the same knowledge, experience, or even access to the same AI, creating advantages and disadvantages. And I'll add my own bit to that, connecting back to Tor's provocation earlier around kind of streaming between leaders and apprentices.
So I guess, to respond to that a little bit directly, I mean, we would hope that giving every student access to a super intelligence that's in their pocket, that many universities are paying to subscribe to, or requires a little bit of money month to month, but in terms of the cost of a college degree in the United States, not that much, would even out some of the inequities that we've previously seen. It's always been a fact that certain students have family members or contacts that they can call whenever they have a question about their homework, and others do not because they come from, they're first generation college students. And we would hope that these would even out some of the inequities. And I suspect there's going to be some of that. But the anecdotal data that I'm seeing so far is that it's really widening the inequities, because a lot of the students who already have preparation, who already know the right questions to ask, are able to use the AI in a more powerful and effective way and become sort of these super users, compared to a lot of students who don't seem to have that, that instinct or that training or that culture or what have you. So I suspect that we are going to see a little bit of both, some evening out of inequities, but I suspect there's going to be a lot more inequity as, some students become very adept at this and others do not.
Yeah, a few things to add. First, thank you for the question. I appreciate your bringing up this critical component of thinking about the role and potential of generative AI, and no discussions complete without it. A couple thoughts. The first is, one thing we've been thinking about at the University of Maryland is making some of these kind of foundational, effective ways to use generative AI in introductory classes that every student on campus takes, akin to like a writing class or some like kind of 101, welcome to college, here are skills that you need to develop, which I think is a useful start, but at the same time, need to acknowledge that the students who are enrolling at the University of Maryland is only a small subset, or comparable institutions is only a small subset of the larger population. And there's significant risk of perpetuating existing inequities of those who have access to higher education are those who get supercharged by having these, by knowing how to and having access to these incredible, powerful machines. Often my answer to these questions is to start pushing these knowledge and skills down into K-12 education, which is, in the United States, is compulsory and every student takes it. But that has its own set of really significant challenges. The other part of it, and in some ways this idea of like every student everywhere learning these foundational skills, another, I think, really important part to consider that is exacerbated by a solution of giving the access to every student is acknowledging the impact of these tools on environments and communities where the infrastructure is being set up. I know in the United States, there's been lots of discussion and challenges around these companies identifying kind of less well-off, impoverished communities to construct their data centers because, you know, space is cheaper, electricity is cheaper, and all these negative consequences of building these, you know, massive, you know, data centers that use absurd amounts of energy, and kind of like building it on the backs of communities who have less power in terms of kind of political and socioeconomic kind of levers to pull. And so thinking about what does it mean for ethical, responsible use of these tools, maybe the answer is not anytime I have a question about any, like putting together a shopping list, I'm just going to go ahead and ask generative AI to put together a shopping list, which is, you know, using the equivalent power of running a microwave for 3 years or anything like that. Like, these are things that we need to think about. And I appreciate the question because this has been absent from the conversation up to this point, but really needs to be part of kind of the foundational, like, what does it mean to use these things carefully, responsibly, effectively, ethically? So that's not answers. It's just like more problems, but appreciate your bringing it forward.
Just a sort of a quick response, because I've been interested in this question of the energy usage of AI for quite a while, and like AI as an industry is very energy hungry. But the numbers that I've been seeing recently have suggested that the amount of energy usage for an individual AI prompt keeps on going down and down. And obviously agentic models are bigger, but the last numbers I checked was, I think it was something like an hour of Netflix. Streaming an hour of Netflix is equivalent to somewhere between 20 and 200 prompts to a, you know, slightly last gen AI. And eating a burger is the equivalent environmental impact of about 1,500 prompts to like hundreds of thousands, depending on the model. So as much as I do think that the environmental impact is important, I also think that the learning impact and the potential learning gains is really important here. And I will happily forego my next burger or my next hour of Netflix in order to offset the cost of me using AI as a tool for learning for the next month to year. And, you know, so I want to prod you a little bit, David, and challenge you, since we know each other a little bit on this point.
That's fair, although that impact is not being felt equally by everyone. But yeah, I'm here for the data.
I will keep my hamburger, but you can have all of my Netflix hours. But I think this does connect back to the point I was raised in discussion around when and how and why to use AI and why not to. Is it worth it? There are several questions. We have a little bit of time. I'm going to pose one. I will also direct people to the Q&A feature where a question was posed by an audience member and kindly responded to by Chronis. So thank you so much for doing that. This question open for the group. Each time new technology was introduced to math education, we changed the content knowledge of what we teach. Do you think that with GenAI expansion and entering mathematics, we need to reconsider what mathematics we should teach? And if so, what should not teach? What should we not teach? Another easy question. Irene.
Yeah, thank you for this question. It's quite difficult. I totally agree that every time we have a new tool, we can do mathematics differently, and potentially the mathematical content or our attention to aspects of the mathematical object changes. We saw this a lot since the calculators came in, and there was all this debate: shall we go mental arithmetics or use the calculators? A debate that comes until now. So there is a change. It's not clear what we can keep and what we can put on the side because of the new tool. We will face those decisions. We have started facing them actually. But I feel that we need to go back to the some of the questions that so far we were feeling comfortable with, like the mathematical structure. We had assumptions about the quality of the mathematical argument and what is the appropriate justification, what a proof is, what an exploration. We were comfortable with inductive, deductive, abductive reasoning, and as we were working, building hypotheses, those things might be revisited and go back to the definition of those terms, because now things that were expected to be done by humans can be easily by GenAI, and then we need different actions from the humans. So we may find ourselves going back to the mathematical structure and rethink or refresh of what a a good mathematical argument is.
Thank you, Irene. And we have just a minute or so left, but Chronis for the last word before we wrap up.
Yeah, I mean, I've been exercising for many years to ask the question, what mathematics is good for learning mathematics? And in mathematics education, we're quite sticky with respect to curricula. This is one more reason to start asking this question. What is helpful to us is two ideas. One is the idea of restructurations by Uri Wilensky and Papert, rethinking of the ways in which mathematics is structured in different kinds of curricula, and weeding out areas of mathematics which are not considered as units of mathematics, like curvature, for instance. And the other one is conceptual fields, to take Gerard Vergniaud. So not to think in terms of concepts, but to think in terms of triads, representation systems, and set of situations, and concepts that are connected to each other. So these are ways of addressing the issue, so to speak. And for certain, now that we have a new representational medium, we need to go back into that question yet again, and start problematizing the mathematics that we feel is good for teaching. It may not be so good anymore. We may need to think of different avenues to get students to enjoy mathematical thinking and have fun.
Thank you so much. And thank you to everyone who submitted questions that unfortunately we did not get a chance to discuss. The recording for today's session will be available on our website in about 2 weeks if you want to revisit the ideas. We also invite you to please take a moment to fill out our exit survey. And this is a space where if you want to share your questions there, we can follow up as well as ideas of how you might like to see the conversation continue, because clearly there are a lot of interesting thoughts and a lot of questions still to be addressed. And otherwise, thank you very much from all of us. We appreciate your time. We're very grateful to our speakers for joining us today and sharing their thoughts and provocations. So thank you. I'll turn it over to Chantal for the last word. Have a nice Friday.
Thank you, Amy. Thank you, everyone, for attending and for your great questions that you have sent us. We have put the link for the exit survey in the chat, so please take a moment for this. Thank you again to the panelists for having taken the time to prepare and taking the risk to come and share your thoughts and your expertise on this topic that keeps evolving and keeps changing in a way. But it's very useful to have these insights for us to continue our thoughts on how to move forward in this area. Thank you, everyone. Thank you again for the fields for their support. Thank you to Amy and Elise for joining me with the co-hosting of this event. Thank you, everyone. Have a nice weekend.
Thank you very much. Have a nice weekend.
Have a nice weekend.